Hi and Assalamualaikum. We are from Group A are presenting about the smart transmitter. My name is Abu Hassan bin Razali and my group member are Muhammad Farid Nakib, Tun Irwan Shah, Ahmad Fikri, Muhammad Nazmi, Muhammad Afiq Azwan, Muhammad Nur Shukri. Now, for the introduction, I will be presenting. What is the smart transmitter? A microprocessor based a smart transmitter has memory that can perform calculation, produce their diagnostic and outperform older, more conventional transmitter when it comes to accuracy stability. A smart transmitter will also have a wireless communication protocol which can be used to interrupt the measure value of the transmitter and to customize different transmitter setting. Next, basic component that have in the smart transmitter. ROM and RAM, the operational program of the device, consideration of the CPU, power use, import for field instrument, digital to analog signal, generate provide backward compatibility with existing system and faster update that may be available through digital communication. I/O remote communication. It allows the instrument to communicate by directional as opposed to the analog transmitting paradigm for analog instrumentation in one way. And then last, analog to digital. It's come to system overall efficiency by far the most critical feature. So that's all from my part. Now I will pass to the next presenter, that is Muhammad Farid Nakib. Thank you.
Hello, Assalamualaikum. My name is Muhammad Fakir bin Yasmin. Okay, I will presenting about type on the smart transmission. They have smart two type on the smart transmission, which is hard and smart. For the hard, which mean is highway addressable remote transmission. Okay, for the smart, we for the long name for the smart is single modulation auto range remove transducer. For the hard, we know that transmission hard transmission compress both traditional analog milliampere signal and superimposed optical signal over the analog. Uh, on this, we know that transmission traditional analog MA is compressed together with optical signal over the analog signal. This A complain that with the modern system, since is still have analog signal. The hard model allow the instrument to communicate digital with each other over the same two wire using transmission and analog instrument signal from 4 milliampere to 20 milliampere. On this, we know that the HUD can connecting with the digital communication using two wire uh, from uh, from digital from each component. Okay, next is smart transmission. Smart transmission is opposite to analog transmission that have a microprocessor as their integral component, which allow the self diagnostic ability. And next is non-linear compensation. Next, regain without doing calibrate and analog to communication digital over the network and better accuracy. This the smart transmission have a better transmission on the hub because the smart transmission have compact the more component on the accuracy about the accurate about the data that we can have. Okay, next is smart transmission illustration, which is a simple topology for the smart transmission, which is the control go on the control, the input come and come through the communication is can go through 4 to 20 milliampere and go to transmission. From the control, we know that the analog go the control came on the center communication and elaborate convert that digital signal and go to the communication. That's all. Okay, I give the next presenter to Tony.
Assalamualaikum and hi, my name is Tony Ruanshan bin Amir and I will explain to you about how the smart transmitter works. Okay. First thing, we must know about the basic parts of the smart transmitter. Smart transmitter consists of the four basic parts, which is the process sensor, an analog to digital converter ADC, a microprocessor and a digital to analog converter DAC. Okay. These basic parts can be organized into three basic sections, which is number one, input, second, conversion, and the third, output. Next. Okay. This is the block diagram of the smart transmitter. Okay. Here we can see the sensor, and then the input section, and then conversion section. Stick with the memory and output section. Okay, next. Okay, for the input section comprises the process sensor or transducer and the analog to digital converter ADC. The sensor measures the process variable of interest, such as pressure, temperature, flow, which is then converted into a proportional electrical signal. The measured electrical signal is then transformed to a digital count by the analog to digital converter ADC. This digital count, representative of the process variable, is then fed into the conversion section, which contains the microprocessor. But the microprocessor must rely upon some form of equation or algorithm to relate the raw count value of the electrical measurement to the actual process variable of interest, such as temperature, pressure, or flow. The principal form of this algorithm is usually established by the manufacturers of the smart transmitter, but most hard transmitters include commands to perform field adjustment. This type of adjustment is often referred to as a sensor trim. The output of the input section is a digital representation of the process variable. Next. Okay, next, conversion section. This section contains a microprocessor whose basic function is a mathematical conversion from the process variable to the equivalent MA representation of the process. Closely connected to the microprocessor is the memory, where the setup, configuration, and diagnostic data of the transmitter are stored. The range values of the transmitter related to the zero and span values are used in conjunction with a transfer function to calculate this MA value. A linear transfer function is the most common, although pressure transmitter may have a square root option. Still, many other forms of transfer function can be used with the processor or can be user-defined. The output of the conversion section is a digital representation of the desired transmitter output. When you read the loop current using a handheld field communicator, this is the value that you see. This overrides the normal output of the conversion section and replaces it with a specified output value. Output section. In this section, the calculated MA value representing the process variable is fed into a digital to analog converter, where the MA value, milliamp value, is converted into the actual analog 4 to 20 MA electrical signal. Microprocessor must rely on some internal calibration factors to get the correct value of this output. Adjusting these calibration factors is referred to as a current loop trim or 4 to 20 mA trim. Okay, that's all for my part. Next, I will pass the next slide to the Aiman Fikri. Thank you.
Okay, my name is Aiman Fikri and I will present advantage and disadvantage of smart transmitter. Okay, for advantage, a smart transmitter will have a self-diagnostic capability and once can plan for maintenance requirement. Smart transmitter have a calibration capability that allow the removal of zero drift and sensitivity drift error. Smart transmitter consists of multiple sensor and covering various measurement range and allow automatic selection of the required range. Smart transmitter also long-term stability can be improved, recalibrate, frequency can be reduced. Next slide. Okay, some some transmitter like temperature measurement have the facility to connect redundant sensor, which is not possible with ordinary transmitter. Okay. In the event of failure of one sensor, the other sensor help to find the temperature, which improve the plant reliability. Okay, configure data that has stored under the same tag can be transferred from handheld communication or from DCS system. Okay, for disadvantage, as a part of preventive maintenance, calibration or validation cannot be avoided through the transmitter smart.
My name is Muhammad Afi Azwan, Disabli. Okay, I will go to for discussion. Next slide. Okay, for discussion, what is transmitter? Transmitter is used to measure variable in industrial application. Even if conventional transmitter will working just fine, various industrial application demand precision, performance, and reliability. Therefore, for the smart transmitter have gained significant in recent years. This post help you understand the difference between the conventional and smart transmitter and what make smart transmitter a better option. Next. Okay. For conventional transmitter is used to a set of electronic elements. They are used for transmitting the signal in the form of electromagnetic wave. In the transmitter, the operator can only deal with process variable signal sign 4 until to 20 milliampere range of transmitter regulate a limited load current. Next. Okay, and for the smart transmitter is work on the function of microprocessor for signal transmission. It work on the HART protocol due to which atmosphere reading are compensated during digital communication. Unlike a conventional transmitter, it can take a zero span reading and also offer frequency shift key. Okay, next. Okay, I will pass to Muhammad Nazmi for the difference between conventional transmitter and smart transmitter.
Hello, and I'm Muhammad Nazmi with Muhammad Rusdi. So here, the point I'm giving here is already been stated on advantages, but the purpose on this difference are made to compare the conventional transmitter and smart transmitter. As far as you can see, the range ability for conventional transmitter only offer 5 to 1 for the range ability, while smart transmitter managed to give hundreds to 1 range ability. So the range ability here obviously shows that the smart transmitter, highly accurate without any calibration, is far more usable than conventional transmitter. For the accuracy, the smart transmitter applies self-instrument loop identification for signal processing, and this self-instrument loop identification increase the accuracy for the smart transmitter, while the conventional transmitter doesn't perform zero span adjustment that will lead to deflect for error on reading value by 2 to 3%. And next we go to the interface. Unlike conventional transmitter, the smart transmitter have a feature of local operational interface, that is LOI, that allows changing the device configurations. This feature is helpful when the smart transmitter are set in the calibration device. This LOI is a screen on the transmitter which allows the operator to commission the device depending on the application. And the digital communication between these both transmitter are different. For the smart transmitter works on highway address remote transducer. Highway address remote transducer protocol is a digital communication protocol that allows smart transmitter to superimpose the analog signal, while conventional transmitter only works on basic loop current that generate electromagnetism principle that does not allow digital reading. Smart, smart transmitter can also communicate by foundation fieldbus, and profibus. So fieldbus is simply a means of communicating with input device such as sensor, switch, and otherwise, without the need to connect each individual device back to the controller. So I will pass the next part, that is conclusion, to Muhammad Nur Shukri.
Okay, I'm Muhammad Nusukri bin Abdul Alim. So I will to explain about conclusion. So for the conclusion, as we can conclude, the smart transmitter is more useful for industry because its range for measure is much better than conventional transmitter. So other than that, smart transmitter is more accurate in measurement without any calibration. This makes smart transmitter is suited for the petroleum industry and other challenging industry where regulator conventional transmitter fail. So that's all for this